Since the Industrial Revolution, humans have emitted more CO2 and other carbon-based gases into the atmosphere, which is starting to affect our climate. The concentration of CO2 in our atmosphere has moved up above over 400 parts per million. Part of our Paris Climate Accord requirements was to keep it below that point, but we are already above it. We can fingerprint the CO2 in our atmosphere and tell what concentration of CO2 is coming from hydrocarbons and what is coming from naturally occurring events. CO2 on its own is not necessarily bad. In fact, trees and plants use it to grow every day. As we are increasing the amount of CO2 around our planet, we're actually seeing a greening effect as more plants are using that CO2 and growing. That being said, when we increase the concentration in our atmosphere, the way the sun rays interact with our planet is changing. The rays come down from the sun, hit the planet, and are no longer able to escape because of that increased concentration in CO2. We call that a greenhouse gas effect. If we're going to hit our global CO2 emission reduction targets, there's a multitude of approaches. First of all, we need to figure out a way to stop emitting CO2 at the levels that we are. So that could be forms of perhaps electrification, moving into electric cars, dealing more with electrification and less with combustible engines. We still have quite a few hard-to-abate industries that will always be emitting methane or CO2, and we need to figure out the best way to stop those emissions from those sources. And that's cement, petrochemicals, steel, for example, all things that we need and we can't get rid of. So how do we stop those emissions from getting into the atmosphere? And that's how we start to get into the carbon capture space. We can think about our emission profile as a bathtub with the tap filling up the bathtub, and that's our CO2 moving into our atmosphere. So if we use carbon capture, that's pulling the CO2 right off of the tap. That's stopping those emissions from filling up the bathtub. But we need to also talk about how do we get more water out of the tub. We've got our parts per million of CO2 in the atmosphere much higher than we'd like. And we're starting to talk about direct air capture and different technologies to pull the water, to pull the CO2 out of the atmosphere. Once we've captured the CO2, the preferred process by governments is to take that CO2 and inject it into saline aquifers, so that's salty, wet reservoirs into the subsurface. The reason this is the preferred process is because we've been doing some form of injection, some sort of fluids into those saline aquifers since the 1960s. We understand that process really well. The reason we want to do it in a saline aquifer is because the CO2 itself dissolves into the water, and we end up with a bubbly water, just like your soda stream, just like your pop. Eventually, over time, the carbon from CO2 precipitates out, falls out of that system, and we're left with a oxygenated water system and pure carbon sitting in the bottom. If we're injecting into depleted oil and gas reservoirs, there's two different ways to look at it. We can look at it as straight storage, where we inject the CO2 into the open porosity and permeability that sits in the subsurface, or we've been doing enhanced oil recovery, EOR, for decades in Canada, in the US. And that's where we inject CO2 into the reservoir, use it to build a pressure front and push existing resources, either oil and gas, out into adjacent wells to produce it. And that form really could help build a net zero oil and gas production while supporting the infrastructure to build out storage in those depleted oil and gas reservoirs. Global drivers for CCS is our decarbonization goals that we've set. So the Paris Climate Accords are Canadian decarbonization goals. CCS, carbon capture and storage, is something that we understand and we have the infrastructure and the ability to do today. It's something we can implement right now, and we don't have to worry about the accelerating of different technologies to get us moving.